Dear students, in this lecture we will discuss about some more examples of half-range Fourier sine or cosine series. Let us take an example. Express fx is equal to x as a half-range cosine series in the interval 0 less than x less than 2, and second part is half-range sine series in 0 less than x less than 2. Now first we find out, here function is given, here function is fx is equal to x, okay, and we have to find out half-range cosine and sine series for the same interval 0 less than x less than 2. That is, here interval is 0 less than x less than 2. Now first we find out half-range cosine series. Half-range cosine series for the function fx is equal to x is equal to a0 by 2 plus summation n equal to 1 to infinity cosine series, half-range cosine series for the interval 0 less than x less than L is defined by a0 by 2 plus summation n equal to 1 to infinity an cos n pi x upon L. Okay. Now when we compare these two intervals, 0 less than x less than L and 0 less than x less than 2, what is the value of L? Here value of L is 2. That is, now we can write fx is equal to x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x upon 2. And suppose this is the equation number 1. We put here value of L. We can compare these two interval. Value of L is 2. Now formula of A0. We can find out A0. Formula of A0 is, this is 2 upon L, 0 to L, f of x dx. Here L is equal to 2 means 2 upon 2, 0 to f of x is x dx, and when we integrate this is just will be cancel out, and integration of this x square by 2 and limit is 0 to 2, and when we apply this limit we have a0 is equal to 4 by 2 minus 0, that is a0 equal to 2. Now we find out second Euler's coefficient an, and formula of this an is 2 upon L, 0 to L, fx cos n pi x upon L dx. Here value of L is 2, that is 2 upon 2, 0 to 2. Well, here function is given fx is equal to x, and here cos n pi x upon 2 dx. Okay. Now we integrate by parts, taking x as a first function and cos n pi x upon 2 as a second function. That is an is equal to, these two will be cancel out. First function means x. Integration of cos n pi x upon 2 will be sine n pi x upon 2 upon n pi upon 2, or we can write it 2 upon n pi, and integration of this sine n pi x upon 2. Okay, in step by step, if we assume this n pi x upon t, then n pi dx is equal to dt, then we can divide this term. Okay, so here we have finally 2 upon n pi sine n pi x upon x, integration of this cos n pi x upon x, minus differentiation of first is 1, and integration of second. Now in this term, integration of sine is minus cos. Okay, sine theta is minus cos theta, or sine x is minus cos x, or sine n pi x upon 2 is minus cos n pi x upon 2 a whole upon n pi upon 2, or we can write it minus 2 upon n pi, and here we have cos n pi x upon 2 and limit is 0 to 2. Okay, now we simplify these equations. Here this minus and this minus we can write down here plus. Now first we apply upper limit. Here upper limit is x is equal to 2. What we have when we apply upper limit? Upper limit x equal to 2, that is 2 into 2 upon n pi, and here we have when x equal to 2, 2 will be cancelled out, that is we have only sine n pi. Okay, we have what we have here, when we put x equal to 2, sine n pi, and value of sine n pi is 0. We can write here this into 0, plus when we put x equal to 2 here, what we get? 2 upon n pi, and here when we put x equal to 2, cos 2n pi upon 2, that is 2 cancel out, we have cos n pi, and we know that cos n pi is minus 1 to the power n. Okay, we have cos n pi is minus 1 to the power n. Cos n pi is minus 1 to the power n. And when we integrate, okay, 2 upon n pi, when we integrate this term second time, this will be 2 upon n square pi square. Okay, actually when we are integrating by parts, this here what we get, first function integration of second minus differentiation of first and integration of second, so mean this will be 2 square upon n square pi square. Please correct it. Here we write 2 upon n pi. In place of 2 upon n pi, it is 2 square upon n square pi square, because we are integrating second time this term. Okay, so we get here 2 square upon n square pi square cos n pi x upon 2. Means what we have? 2 square upon n square pi square, and x equal to 2 means cos 2 to cancel out cos n pi, and cos n pi is minus 1 to the power n. Now we apply lower limit. Lower limit is 0. X equal to 0 means 0 into this term is 0, plus when we put x equal to 0 here, means here we have 2 square upon n square pi square, and here we have cos 0. Cos 0 is 1. That is an is equal to, now this term is 0, what is the common term? 4 upon n square pi square is the common term. Okay, from here and here, what we have inside the bracket? Minus 1 to the power n minus 1. This is the value of an. Now from equation 1, we know that x equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x upon 2. Okay, here value of a0 is 2, that is 1 upon 2 into 2 plus summation n equal to 1 to infinity an means 4 upon n square pi square minus 1 to the power n minus 1, and here we have cos n pi x upon 2. That is x equal to this 2 is cancelled out 1, and what is common here? 4 upon what is the common term? Common term is 4 upon pi square. 4 upon pi square is the common term, and we have n equal to 1 to infinity minus 1 to the power n minus 1 upon n square into cos n pi x upon 2. Okay, that is x equal to 1 plus 4 upon pi square. When we put n equal to 1, it is minus 1 to the power 1. Okay, and that is minus 1 minus 1 minus 1 minus 2, that is minus 2 upon 1 square cos pi x upon 2. Cos pi x upon 2. When we put n equal to 2, here plus 1 minus 1 is 0, so next term will be 0. When we put n equal to 3, we get negative term. Here we have minus 1 minus 1 minus 2, that is minus 2 upon 3 square cos 3 pi x upon 2. Next term will be plus 0, and after that we get term 2 upon 5 square cos 5 pi x upon 2, and so on. On solving this, we get here x equal to 1 minus 4 is the minus 2 is the common term, minus 8 upon pi square. Here we have cos pi x upon 2 upon 1 square plus cos 3 pi x upon 2 upon 3 square plus cos 5 pi x upon 2 upon 5 square, and so on. And which is the final Fourier cosine series, final answer for the half range cosine series. Okay, now we solve second part, half range sine series for the same interval. For the same interval, here function is fx equal to x, and interval is 0 less than x less than 2. We have to find out here half range sine series. Here L is equal to 2. Here L is equal to 2. Half range sine series for the interval, for this interval, is defined by the formula fx is equal to summation n equal to 1 to infinity bn sine n pi x upon L. Okay, that is here L equal to 2, we can write it n equal to 1 to infinity bn sine n pi x upon 2, and suppose this is the equation number 1. Okay, and here we find out bn. Formula of bn is, here formula of bn is, what is the formula for bn? Formula for bn is two upon L 0 to L fx sine n pi x upon L dx. That is bn equal to 2 upon 2 0 to 2 fx means x sine n pi x upon 2 dx. Okay, now we integrate by parts, taking this as a first function and this sine n pi x upon 2 as a second function. Now what we have? This 2 is cancel out. Bn equal to, first function means x, integration of second. What is the integration of sine n pi x upon 2? It is 2 upon n pi, and this is integration of sine is minus cos n pi x upon 2. Okay, this is the integration of sine n pi, 2 minus 2 upon n pi cos n pi x upon 2, minus differentiation of first and integration of second. Integration of second means minus 2 square upon integration of this term 2 square upon n square pi square, and integration of cos n pi x upon 2 is sine n pi x upon 2, and limit is 0 to 2. Okay, that is bn is equal to, here we can cancel out these two minus sign. Here we have now plus sign. First we apply upper limit. Upper limit is x is equal to 2. What we have when we put x equal to 2? When we put x equal to 2, here we have minus 2 into 2, that is minus x equal to 2 into 2, that is minus 4 upon n pi, and x equal to 2 means to cancel out cos n pi. And what is the value of cos n pi? Cos n pi is minus 1 to the power n, that is minus 1 to the power n, plus 2 square upon n square pi square, and here we have sine term, sine 2n pi upon 2, that is sine n pi, and we know that value of sine n pi is 0. Value of sine n pi is 0, that is this term will be 0. Now we apply lower limit. Lower limit is x equal to 0. X equal to 0 means this whole term will be 0. 0 into everything is 0. plus here we have sine 0. Sine 0 is also 0. Okay. Finally, what we have? We have Bn is equal to minus 4 upon n pi minus 1 to the power n, or we can say 4 minus 1 to the power n plus 1 upon n pi. Now from equation 1, or we can say 2, from equation 2 we have x is equal to summation n equal to 1 to infinity Bn sine n pi x upon 2. Okay, and what is the, now we put the value of Bn here, that is summation n equal to 1 to infinity, it is 4 into minus 1 to the power n plus 1 upon n pi, and here we have sine n pi x upon 2. Now we can write down this in the form of series. Here 4 upon pi is the common term, constant term. We can take it out, so we can put here outside the bracket, and we can open it for n equal to 1, 2, 3. When we put n equal to 1, it is minus 1 to the power 1 plus 1 means 2. Okay, when we have an odd value, here we get positive value, and when we have even value, here we have negative terms. That is, when we put n equal to 1, we have 1 upon 1 sine pi x upon 2. When we put n equal to 2, here we have negative term, that is minus 1 upon 2 sine 2 pi x upon 2. Here 2 will be cancelled out. When n equal to 3, we have positive term 1 upon 3 sine 3 pi x upon 2, and when we put n equal to 4, here we get negative term, that is 1 upon 4. Here we have sine, not cosine, sine. 1 upon 4 sine 4 pi x upon 2, and so on. And this is the final answer. This is the half range sine series for the function fx is equal to x in this interval 0 less than x less than 2. Now I would like to take one more example on this half range series for discontinuous function. Okay, now half range sine series for this interval fx is equal to, here function is given, half range, we have to find out half range sine series for the function fx equal to x for the interval 0 less than equal to x less than pi by 2, and it is equal to pi minus x for the interval pi by 2 less than equal to x less than plus pi. Okay, here we know that half range sine series is defined by the formula sine series. Okay, summation n equal to 1 to infinity Bn sine nx. Okay, and this is the equation number 1, and formula for Bn is 2 upon pi. Here interval is 0 to pi, 2 upon pi 0 to pi fx sine nx dx. Okay, now here fx is a discontinuous function. Now what we have to divide this integration in two parts. for this discontinuous function. Here x equal to pi by 2 is a point of discontinuity. Means what we have here, 2 upon pi. Now we divide this integration in two parts. 0 to pi by 2 we have function x sine nx dx, and second integration we have limit pi by 2 to pi. Here we have pi minus x sine nx dx. Okay, that is 2 upon pi. Now we integrate by parts, taking in first part taking x as the first function and sine nx as the second function. First function means x. Integration of sine nx. Integration of sine nx is minus cos nx upon n. Minus differentiation of first and integration of this term. Integration of this term is minus sine nx upon n square plus second integration. In second integration we take pi minus x as the first function and sine nx as the second function, and here in first integration limit is 0 to pi by 2. Now we take second integration. First function means pi minus x, here continue from here, pi minus x. Integration of second is minus cos, integration of sine is minus cos nx upon n, minus differentiation of first, that is minus 1, and integration of second, that is minus sine nx upon n square, and limit is pi by 2 to pi. Okay, now we apply this limit, and we can also simplify the sign. Here these two negative we can write here positive sign. Okay, these two can maybe cancel out, and here we have this negative term, and this is also, so here we can have plus sign. Now we apply the limits. First we put x equal to pi by 2. X equal to pi by 2 is the upper limit. Okay, so first we apply upper limit. It is negative sign, x equal to pi by 2. Okay, that is pi by 2 into 1 upon n this term, and cos n pi by 2, cos n pi by 2, cos n pi by 2, plus next term, what is the next term, 1 upon n square, and here we have sine n pi by 2. Now we apply lower limit, minus lower limit. When we put x equal to 0 means 0 into this 0, and plus sine 0 is 0. Okay, now second part, first we apply upper limit. Here x equal to pi, here integration is 0 to pi by 2, 0 to pi by 2, and pi by 2 to pi. First we apply x equal to pi here, so here we have minus sign, pi minus pi by 2, that is pi by 2, pi minus pi by 2 is pi by 2, sorry. When we put x equal to pi here in this integration, this term will be 0 minus x equal to pi, this will be 0 and 0 into this 0 plus sine n pi minus sine n pi, and also we know that sine n pi is 0. Sine n pi is 0. So here we have 0 minus lower limit is x equal to pi by 2. Now we apply lower limit pi minus pi by 2. Here this minus is common. Pi minus pi by 2, that is pi by 2 up into 1 upon n, and what we have here, cos n pi by 2, cos n pi by 2, and next term minus 1 upon n square sine n pi by 2. Okay. What we have here, 2 upon pi is the common term. Here we have minus pi upon 2n, minus pi upon 2n cos n pi by 2. Okay. Plus 1 upon n square sine n pi upon 2, and here we have minus minus plus pi upon 2n cos n pi by 2, and minus minus plus 1 upon n square sine n pi by 2. Now these two are cancel out. What we have here, 2 upon pi, and here we have 1 upon 2 upon n square sine n pi by 2. Okay, that is 4 upon pi n square sine n pi upon 2. Now from 1 we can put the value of bn here, that is summation n equal to 1 to infinity bn. Bn means 4 upon pi n square sine n pi x upon 2. And also we can open this series. This is clear to all of you, and we can also open it. It is 4 upon n square, that is fx is equal to, when we put x equal to 1 here we have sine pi x upon 2. Okay, means sine pi by 2. When we put n equal to 1 here, sorry, sine nx, this is not n pi x, this is sine nx, fx sine nx. This is fx sine nx, 4 upon pi n square sine n pi by 2 n pi by 2 into sine nx. Okay, and now when n equal to 1, what we get here, 4 upon pi is the common term. When n equal to 1, here we get sine pi by 2, sine pi by 2 is 1, and we get here 1 upon 1 square sine x. When n equal to 2, we have sine pi, sine 2 pi is 0, second term will be 0, when n equal to 3, here we have sine 3 pi by 2, that is plus minus 1, that is minus 1 upon 3 square sine 3x. Next term will be 0, and after that we get 1 upon 5 square sine 5x, and so on. And this is the final answer. I think this lecture is clear to all of you. If you have any queries regarding this half range Fourier series, then you can comment on comment box. And if you feel this lecture is useful for you, then please like and subscribe this channel. Okay, here, okay, sin x, here we have next term is like this. Okay, like and subscribe this channel. Okay, thank you very much. Have a nice day, and Bharat Mata ki jai.